Now, in the last section, we talked a lot about this idea of blowing up and shrinking things proportionally. Well, that proportional amount actually has a name, and it's called scale factor. And mathematically, we always use the variable k. So we're going to look at some examples and some applications about how we find k in real examples and in our geometric examples. One of the most common places that scale factor is used in the real world is in architectural drawings. You can't build a real house and ask people if they like it. You need to come with a scale drawing, but it needs to look like the real house is going to look. The windows have to be proportionally the right size, the height of the ceilings and the roof, etc. And so architects and draftsmen use scale. So they shrink everything by a certain factor. They blow everything up by a certain factor. So our scale and actual drawings in our table for this new barn are given. Our units aren't particularly important because these are all feet. These are all going to be inches. So the length of water line in his scale drawing. So we want to know what this value x is. So we want to think about feet to inches or inches to feet. You always want to be consistent with what you put in the numerator and what you put in the denominator of your scale factor. So if I pick either of these two as my consistent amount, so let's say 16 feet of a door opening equates to 4 inches in my picture, then that needs to be the same proportion of 10 feet of water line to how many inches of water line in my drawing. And if I cross multiply 16x equals 40, I find out and divide both sides by 16 that x is 2.5 inches. So 2.5 inches on my scale drawing equates to 10 feet in my real building. If I record a scale length of 5 inches for a window, what's the actual length? So again, I go back to a pair that I know the relationship, either one of these two. So I'm going to use 16 over 4 again. 16 over 4. Now this time I know the scale factor, 5, and what I don't know is the actual window. So when I cross multiply here, I have 16 times 5 is equal to 4w. If you divide both sides by 4, my window is actually 20 feet. So I can move from scale to actual and actual to scale. Now I can also check my math. He measured his actual window to be 3.5 feet, but recorded the scale as 0.85. Is that correct? So let's put 3.75 over 0.85 and let's see if that is the correct ratio. Now, if I cross multiply, they better be the same. So 4 times 3.75, is that the same as 0.85 times 16? And when you do those two sides, we end up with 4.41 is not equal to 4, therefore not proportional. So somewhere along the line, the calculations were messed up and he needs to go back and do them. Now, the last question asks about what is the scale factor. Now, scale factor can be reported in a lot of different ways, so you want to read your directions carefully. Here we're saying actual to drawing. So that means you put your actual length on top, 16. Its comparative scale is 4. We always reduce. So what this is saying is for every 4 units in real life, there is 1 unit in my drawing. And if I know that I'm doing actual to drawing or drawing to actual, it helps me set up all of my other proportions. So when I look at a very straightforward example here that says find the scale factor, smaller to larger. So I want to put the smaller on top, corresponding sides. K is 3 over 6. which is 1/2. And it is that straightforward and that simple. When we're given problems to solve for x, you want to be sure to look at the scale factor. My scale factor from a to b is 4/5. This 425 with the colon is another way. It just reports out as a fraction. Make sure you put a on top, 2b equal to 12 over x plus 6. We learned in the first unit section of this that we have to lock those in parentheses before we cross multiply. 4 times x plus 6 is equal to 5 times 12. Distribute. 4x plus 24 equals 60. Subtract 24. 4x is equal to 16. Divide by 4. X is 4. Same thing here, except be careful. A to b, 3/4 is equal to a to b, 24. A has to go on top. 3x minus 4 has to go on the bottom because that's the b. When my scale factor is a to b, both of your a dimensions have to be in the numerator, your b dimensions in the denominator. When I cross multiply, again, lock those in parentheses. I have 3 times 3x minus 4 is equal to 4 times 24. And so distributive property, I have 9x minus 12 is equal to 96. Add 12 to both sides, 9x equals 108. Divide by 9, x is 12.